Hello, my name is Alex Rappaport, and recently I became physics and math tutor. So physics involves a lot of math, and my goal is to teach you, give you knowledge retained for life rather than prepare you for passing tests and forgetting it. And even more so, I want to teach you for excellence. And with that being said, first I want to introduce the book that I like. I checked all the books that I could find in the public library. This is the best in my opinion. And second, what I will be doing, I will be introducing questions, problems that have elegant solutions that will require you time and effort to come up with. And this was end of part one. So part two is the problem that I want to introduce you to. So imagine you have a room, and here's a spider, and here's the catch, like a fly. And spiders, one thing, they can crawl on the wall, they can crawl on the floor, on the ceiling, they cannot fly. So you need to find the shortest way for this spider to get to the fly. So imagine you would go down the wall, then you would go along the room. So your way, this will be a very long way, h plus a plus b. Now with the blue, I highlight with the blue when all dimensions equal to 1. All dimensions are same, a specific case of a cubical room. In this case, the length will be 3. Okay, now imagine the spider would be able to fly. It would be a square root of h squared plus a squared plus b squared. So the square root of 3 is 1.732, except spiders cannot fly, so this way is out. And when I say this, I assume you're familiar with the Pythagorean theorem. If let's say this is my room, and this is my dimension A, and this is my dimension H, which is the height of the ceiling, this line called hypotenuse would be square root of a squared plus h squared. I assume you know that. So somebody would say, let the spider go down and then go diagonal across the floor. So in this case, it would be h squared plus square root of a squared and b squared. So I give you a hint. No, it is incorrect. You can do better. Now let's make a pause. Try to come to solution. Okay, so after the pause, what did you come up with? So you remember we discussed the longest trajectory, which would be 3 in the case of cube. We discussed the shortest trajectory, which is square root of 3, but it is impossible because spider cannot fly. And now this is the box. The spider needs to get from here all the way to here. So I flatten it. And here is the spider, and here is the spider. It could sit on either side of the cut up box. So which way is shorter? This way or this way? So if the spider would go down and then diagonal, it would be through the red trajectory. It would be h plus square root of a squared plus b squared. 1 plus square root of 2 is 2.414. But really, it doesn't have to. It can go this way. And that would be the shortest path, either this or this. So, in this case, it would be square root of h plus a squared plus b squared, or h plus b squared plus a squared. So it can start from here, it can start from here, whichever way is shorter. And in case of a cube, it would be square root of 5, which is 2.236. And this is the solution. So I hope you appreciate and enjoy the brightness and elegance of this task. Also, by the way, there's another option. If you cut the box differently, you can get this way. Square root of h squared plus a plus b squared. So if the room is very, very tall, if it's taller than its to other dimensions, this path would win. Thank you. This was part 3. Okay, so here's your home assignment. And this one, you have a square, and on one side of a square you have a right triangle with sides A and B. Whatever they are, this is the right angle 90 degrees. And obviously you understand that A squared plus B squared equal to C squared. Now I make a line between the center of this square and the right angle, and I call it L, big L. I give you a hint what L equals to. It is A plus B divided by square root of 2. But the assignment is please prove it. If you start writing many formulas with sinus and cosinus and so on, you lose it. You don't need to write many lines. You just, like in the previous task, you just need to get this elegant solution. And there is a bonus question. Using this picture, prove the Pythagorean theorem that we discussed. This picture allows you to prove the Pythagorean theorem very elegantly. That's the bonus. Thank you, and I hope to see you next time.